Welcome to Simplifying STEAM. Extreme sports are those that involve high levels of physical exertion, speed, danger, and thrill. Some popular extreme sports include snowboarding, skateboarding, surfing, BMX biking, skydiving, rock climbing, base jumping, bungee jumping, and parkour. These athletes often perform incredible feats of athleticism and skill that seem almost impossible. But what makes them able to do this? The answer lies in physics. The laws of physics govern how objects move, how forces interact, and how energy is transferred. By understanding the basic principles of physics, extreme sports athletes are able to manipulate and use energy, momentum, and forces to achieve the goals. For example, let's take a look at snowboarding and skateboarding. These sports involve jumps and spins that require the athlete to generate and manipulate their own momentum. By changing the position of their body and the distribution of their weight, they can control their rotation in the air. In surfing, athletes must also understand the physics of waves. Waves are essentially disturbances in the water that travel through the ocean. By reading the shape, speed, and direction of a wave, surfers can ride it and perform maneuvers. Skydiving involves the physics of freefall and the use of parachutes to control descent. The faster an object falls, the greater its air resistance. Skydivers use this principle to slow themselves down by opening their parachute at the right time. Rock climbing involves the principles of friction, tension, and gravity. By understanding the relationship between the frictional force of their body against the rock, the tension in their muscles, and the force of gravity pulling them down, climbers can ascend a cliff. And in parkour, athletes use the physics of motion and energy transfer to navigate through complex environments. By optimizing the speed and direction of their movements, they can overcome obstacles and reach their destination. Skateboarding is a sport that involves riding and performing tricks on a skateboard. It's a popular extreme sport that requires a combination of balance, skill, and speed. But how do skateboarders perform those amazing tricks? It all comes down to physics. Skateboarding involves a number of physics principles, including Newton's laws of motion, the conservation of energy, and the principle of torque. Let's start with the most basic trick in skateboarding, the ollie. An ollie is a jump where the skateboarder jumps into the air with the skateboard still under their feet. To perform an ollie, the skateboarder pushes down on the tail of the skateboard, which causes the nose to rise up. This is known as the pop. Then, the skateboarder slides their front foot up the board, which levels the board in midair. Finally, the skateboarder lands back on the board, absorbing the impact with their legs. Skateboarders can also perform more advanced tricks like kickflips and heel flips. These tricks involve spinning the board in the air while the skateboarder remains in control. To perform a kickflip, the skateboarder kicks the board with their front foot while simultaneously flicking the back of the board with the back foot. This causes the board to spin and flip in the air. Skateboarders can also perform grinds, where they slide along the edge of a rail or ledge with the trucks of the skateboard. To perform a grind, the skateboarder approaches the rail or ledge at an angle and jumps onto it, balancing on the trucks of the skateboard. They use their body weight and balance to maintain control and slide along the rail. These are just a few examples of the physics principles involved in skateboarding. By understanding the laws of physics, skateboarders are able to manipulate and use energy, momentum, and forces to perform these incredible tricks. But don't take our word for it, let's see how professional skateboarders put these principles into practice. Professional skateboarders like Tony Hawk, Rodney Mullen, and Nigel Houston have mastered the physics of skateboarding, and use these principles to push the limits of what's possible on a skateboard. Snowboarding is a popular extreme sport that involves riding down snow-covered slopes on a snowboard, performing tricks and maneuvers along the way. But how do snowboarders perform those incredible jumps and spins? Snowboarding involves a number of physics principles, including Newton's laws of motion, the conservation of energy, and the principles of rotational motion. Let's start with the most basic trick in snowboarding, the jump. A jump involves riding down a slope, launching into the air, and then landing back on the slope. To perform a jump, the snowboarder rides down the slope and then compresses their body, storing potential energy. They then launch into the air by extending their body and releasing the stored energy. Finally, they use their body position and the angle of their board to control their landing. Snowboarders can also perform spins, where they rotate their body and board in the air, and grinds, where they slide along a rail or box on their board. These are just a few examples of the physics principles involved in snowboarding. By understanding the laws of physics, snowboarders are able to manipulate and use energy, momentum, and forces to perform these incredible tricks. But don't take our word for it, let's see how professional snowboarders put these principles into practice. Professional snowboarders like Shaun White, Chloe Kim, and Mark McMorris have mastered the physics of snowboarding, and use these principles to push the limits of what's possible on a snowboard. Surfing is a sport that involves riding waves on a board, using your body to control your speed and direction. But how do surfers manage to ride those massive waves and pull off those amazing tricks? Surfing involves several physics principles, including wave mechanics, buoyancy, and fluid dynamics. Let's start with the most fundamental principle of surfing, wave mechanics. Waves are created by wind blowing over the surface of the ocean, and these waves travel through the water until they reach the shore. To surf a wave, a surfer paddles out to where the waves are breaking and waits for the right wave to come along. When the surfer spots a wave, they paddle towards it and start to feel the energy of the wave lifting their board. They then pop up onto their feet and use their weight and body position to control their speed and direction. By understanding the shape and movement of the wave, surfers are able to ride it and perform maneuvers like cutbacks, floaters, and aerials. One of the most exciting tricks in surfing is the aerial, where the surfer launches into the air and performs a spin or flip before landing back on the wave. To perform an aerial, the surfer uses the energy of the wave to launch themselves into the air. They then use their body position and weight to control the spin or flip, before landing back on the wave with precision. Another impressive trick in surfing is the barrel ride, where the surfer rides inside the hollow part of the wave. To perform a barrel ride, the surfer positions themselves just in front of the breaking part of the wave, where the wave is hollow. They then use their weight and body position to ride inside the barrel, staying ahead of the collapsing wave and emerging from the other end. Professional surfers like Kelly Slater, Gabriel Medina, and Carissa Moore have mastered the physics of surfing and use these principles to ride bigger and more challenging waves and perform incredible tricks. BMX biking is a sport that involves riding and performing tricks on a small bike with a 20-inch wheel. But how do BMX bikers manage to pull off those gravity-defying moves? BMX biking involves several physics principles, including friction, gravity, momentum, and center of mass. Let's start with friction. Friction is the force that opposes motion when two surfaces are in contact with each other. In BMX biking, friction is important for maintaining control of the bike and landing tricks. BMX bikers use the friction between their tires and the surface they're riding on to perform tricks like grinds and slides. Next up is gravity. Gravity is the force that pulls objects towards each other. In BMX biking, gravity is crucial for getting air and performing tricks. BMX bikers use their weight to manipulate their bike's trajectory and create tricks that defy gravity, like tail whips and backflips. Momentum is another important physics principle in BMX biking. Momentum is the product of an object's mass and velocity, and it helps BMX bikers generate speed and perform tricks. BMX bikers use their momentum to jump higher and further, and to spin faster when performing tricks like 360s and 720s. Finally, center of mass is a key physics concept in BMX biking. The center of mass is the point at which an object's mass is evenly distributed. In BMX biking, BMX bikers use their body position to control their bike's center of mass and perform tricks like bar spins and whips. Skydiving is a sport that involves jumping out of a plane or other aircraft and free falling through the air before deploying a parachute to slow down and land safely. But how do skydivers manage to jump from thousands of feet in the air and land safely on the ground? The answer is physics. Skydiving involves several physics principles, including gravity, air resistance, terminal velocity, and freefall. Let's start with gravity. Gravity causes skydivers to accelerate towards the ground during freefall. Skydivers use their body position to control their descent rate and achieve a desired speed during freefall. Air resistance is another key factor in skydiving. Air resistance is the force that opposes motion through the air, and it increases as the speed of an object increases. Skydivers use their body position and their parachute to control their air resistance and slow down during freefall and landing. Terminal velocity is the maximum speed that an object can achieve when falling through the air. In skydiving, Terminal velocity is reached during freefall and is influenced by the skydiver's body position, weight, and air resistance. Skydivers use their body position to control their terminal velocity and achieve a desired speed during freefall. Finally, freefall is the period of time during a skydive when the skydiver is falling through the air without a deployed parachute. Freefall is where skydivers perform the most complex maneuvers and stunts, using their body position and air resistance to control their speed and direction. So there you have it. The physics of skydiving is all about gravity, air resistance, terminal velocity, and freefall. Skydivers use these principles to perform amazing feats and land safely on the ground. Rock climbing is a sport that involves climbing up steep or vertical surfaces using only your hands and feet for support. But how do rock climbers manage to climb these sheer cliffs and walls? Rock climbing involves several physics principles, including friction, gravity, center of mass, and force. Let's start with friction. Friction is the force that opposes motion between two surfaces in contact, and it's what allows rock climbers to stick to the rock face and move upward. Rock climbers use specialized shoes and chalk to increase the friction between their hands, feet, and the rock surface. Gravity is another key factor in rock climbing. Gravity causes rock climbers to constantly fight against the pull towards the ground. Rock climbers use their body weight and position to overcome the force of gravity and move upward. Center of mass is also important in rock climbing. Center of mass is the point at which the weight of an object is evenly distributed in all directions. Rock climbers must constantly adjust their center of mass to maintain balance and avoid falling. Finally, force is the key to rock climbing. Force is the push or pull on an object that can cause it to move or change direction. Rock climbers must use their muscles to generate force and pull themselves upward, using the principles of leverage and momentum to their advantage. So there you have it. The physics of rock climbing is all about friction, gravity, center of mass, and force. Rock climbers use these principles to scale vertical walls and cliffs, using their strength, skill, and technique to reach new heights. Base jumping involves jumping from a fixed object, such as a tall building or cliff, and using a parachute to slow your descent and land safely on the ground. But how do base jumpers manage to jump off such high objects and land safely on the ground? Base jumping involves several physics principles, including gravity, air resistance, velocity, and energy. Base jumpers use specialized wingsuits to increase their surface area and create more air resistance. Velocity is also important in base jumping. Velocity is the speed at which an object is moving, and it's what allows base jumpers to cover large distances as they jump off a fixed object. Base jumpers must carefully calculate their velocity and trajectory to ensure they land in a safe area. Finally, energy is the key to base jumping. Energy is the ability to do work, and it's what allows base jumpers to overcome the force of gravity and achieve lift. Base jumpers use their own energy, as well as the energy of the wind and air currents, to stay in the air and control their descent. Bungee jumping involves jumping off a high platform or bridge while attached to a long elastic cord, and experiencing the thrill of free fall before bouncing back up and down several times. But how does the cord manage to support the weight of the jumper and prevent them from hitting the ground? Bungee jumping involves several physics principles, including gravity, potential energy, kinetic energy, elasticity, and friction. Potential energy is another key factor in bungee jumping. Potential energy is the energy an object has due to its position or height, and it's what allows bungee jumpers to experience the thrill of free fall as they jump off a platform. As the bungee cord stretches, the potential energy is converted into kinetic energy. Elasticity is the most important factor in bungee jumping. Elasticity is the property of a material that allows it to stretch and return to its original shape. The bungee cord is made of a special elastic material that can stretch and compress several times without breaking. Friction is also important in bungee jumping. Friction is the force that opposes the motion of an object through a surface, and it's what allows the bungee cord to grip the jumper's body and prevent them from slipping out of the harness. Parkour is a thrilling and challenging sport that requires both strength and agility. Let's take a closer look at some of the key physics principles at play in parkour. One of the most important concepts in parkour is the relationship between distance, time, and velocity. Parkour athletes need to be able to quickly and accurately judge how much distance they can cover in a certain amount of time, and how much velocity they need to achieve to make a successful jump or landing. This requires a good understanding of concepts like acceleration, momentum, and center of mass. In order to make a successful jump or landing, Parkour athletes need to be able to control their body's momentum and maintain their center of mass in order to stick their landing. Another important concept in parkour is the conservation of energy. When a parkour athlete runs up a wall, they are using the energy from their legs to push off the wall and propel themselves higher. By conserving their energy and using it effectively, they are able to achieve incredible feats of athleticism. Finally, parkour also involves a lot of rotational motion. When a parkour athlete performs a flip, they need to be able to control their rotational motion in order to make a smooth and successful landing. These are just a few of the many physics principles involved in parkour. By mastering these principles and using them effectively, parkour athletes are able to push themselves to new heights of athleticism and accomplish feats that many would consider impossible. Thank you for joining us on this journey. Hope we inspired you through this video to do something exhilarating. Don't forget to like and subscribe to our channel for more content on science and technology. Until next time, keep exploring.